5.6, the grade 9 academic course. This is a lesson, it's nothing new, it's just putting a lot of stuff together that we've done up to now, and you'll have lots of time to work on sort of related questions tomorrow in class. It is a connection of everything we've done so far. Partial, direct variation, slope, first differences, rate of change, everything that we've talked about in this unit. And you'll see that the questions get a little bit more challenging. So hopefully you have down our goal, what you should be able to do before we move on to the next section. And here's our first example. So imagine you have this relation, and the relationship in this case is depicted by this graph, and we want to find the slope. Well, first of all, pretty easy. First thing we're going to do is make a right angle triangle. You can do between any 2 points. I've told you this before. Easiest to pick two that lie nicely on the grid. So I picked the y-intercept, 0 and minus 2. Okay, and up here, 2 and 1. And then you find the rise, you find the run. In this case, the rise is 3 because you're going up from minus 2. 1, 2, 3 is my rise, and my run is 1, 2. So that gives me my slope m, or 3 over 2. The vertical intercept, y-intercept, however it says, it's b, however you want to say it, it's where the line crosses this axis, the y-axis, so that's -2. And then the equation's easy. It's always in this form, y equals mx plus b, so it's y equals 3 over 2x minus 2. Every time you write an equation for a line, you're going to have something with a y in it, an x in it, and then that should be the only two variables. Everything else should be letters by the time everything else should be numbers by the time you're finished. Okay? Alright, moving on to the next one. In this one, it's giving us the relation, it's giving us the equation, and asks us first to find a table of values, knowing that there's different ways you can represent a relationship. Here's an equation. It's asking us to make a table of values. Would be a second way. That would be doing it by numbers, and then it asks us to graph it last. So just so you see, it says between 0 and 4. So on my table of values, 0 to 4, find the y values for all those. And here I just went, minus 3 times, in this case, 0. So you sub 0 in, plus 2 equals 2. In this one, minus 3 times 1, because x is 1. Right, you sub in the different values of x to get your table of values. So your y values are here. So then you just have to plot those on the grid. Now truthfully, you only need to plot 2, and that's all I'm going to do. You only need 2 points to make a line. So I'm going to pick 2 points. I'll pick 0 and 2 right here. X is 0, y is 2. And I'll pick the second point, which is 1 and minus 1. So x is 1, y is minus 1. Here. And that's all you need to make a graph. You don't need any more lines than that, or any more points than that. So I'm just going to connect those two with a line. And then you can make that line can go off in either direction forever. It doesn't have to start and finish at those 2 points. So I'm going to write my line here, just make sure it goes through the 2 points, make it go forever. Your line should have arrows on either end, so I can do that sort of through this program. It should start and finish with an arrowhead, because there's no reason that this line couldn't go on. This line could go on until x is 1,000,000 and y, or x is negative 1,000,000 and y is 10 million, or it can go on forever, right? So we do the arrows to represent that. Okay, done. Moving on. Here's another one. So here we have the relationship is represented by a table of values, or numbers, and we want to find other ways to represent it. So it asks us to find the slope. Often we did in previous lessons, we used the first differences to find the slope. This one it doesn't work, because see how the x goes up by 2's? So you can't do it that way. If the x does not go up by 1's every time, you cannot use the first differences. But what you can do is use the equation that slope is change in y divided by the change in x. So if I just took any 2 points, you can take any 2 you want. I took the first 2 that were listed, but you could have taken any other 2, it doesn't matter. And then you can find the slope. Sorry, I'm just going to erase that thing. So then you can find the slope just using this equation. The slope is y2 minus y1, x2 minus x1. And so you take the 2 points, make sure that they're in order, and that you sort of identify what's x1, what's y1, what's x2 and y2. So when I substitute in, this is a little bit messy and hard to read, but all I'm doing is saying, y2 is 0.5 from here. So this number came from here. Minus y1, which is negative 0.5. Right here. X2 is negative 1, and x1 is negative 3. And so 0.5 minus negative 0.5 is like adding 0.5, so that's 1. And that's negative 1 plus 3. Negative and negative is plus. Negative 1 plus 3 is 2. So the slope is 1/2, or 0.5. So that's the answer to A. B is, there's either like a fairly easy way to do it for this particular set of data, and then there's a harder way, and I'm going to show you both. The harder way will become more important later in the unit. We want to find, like the y-intercept, just thinking what that is, it's B, okay? So I'm talking about this point right here where I'm wiggling here. The B is the y value when x equals 0. Now, unfortunately, we can't just take that off of we can't just take it off of here because there is no x equals 0. I think the easiest way to answer this question for this particular set of data, though, is looking at the fact that if that's negative 1 and that's 1, 0 is right between those two. So the y-intercept, the B, would be the number exactly between 0.5 and 1.5. And that would be 1, right? That would be the number that's right in between. So that means that the B value is 1. Another way you could do it, and I'm thinking of all kinds of ways here, a second way you could do it would be if you said, okay, if I took -1 and added 1, right? If I was going to just continue this table of values going up by 1s at this point, if I was going to make this 0 instead of 1, then the next value, because really, using the first differences, the next value would be 0.5 plus 0.5. That would be a second way. The third way is using algebra. And if you don't get it today, if you don't really follow what I'm doing today, it'll come again later. So let me just show you and see what you think. So what I'm saying here is one way to find the y-intercept, if it's not given in the table of values, say it was numbers that it didn't work out nicely, like you couldn't just take the middle one or something like that, would be to take the equation, and the equation that we know so far is y equals 1/2 x plus b, because the slope m is 1/2. And then you take any one point, and any of these is 1 point, right? Any set of data from the table of values, and sub that in for y and x, and then you can solve for b. Okay, so if I took the point where x equals -3 and y is -0.5, which is this point here, I put in -0.5 here, 1/2 times -3 plus b, and I'm solving for b. Going through the motions, instead of writing, see, this is 1/2, this is 0.5. I just replaced, because 1/2 is 0.5. Then this line, I said, okay, that times that is -1.5. And rearranging, solving for b, you get b equals 1. So however you do it at this point, this will become more important later in the unit. If you understood what I said the first time by just looking at the numbers and what goes in the middle, that's totally fine. And then the last part of the question was to list the equation, so it's y equals mx plus b. So y equals 1/2 x plus 1. Okay? We also had to describe this relationship using words. So we describe it, you can describe it with a graph, you can describe it with an equation, you can describe it with words, you can describe it with a table of values. Using words, we say, okay, we've got a positive slope of 1/2, and it has a y-intercept of 1. That's why just that information, it's a linear relation, I guess you could add that to a linear relation, positive slope of 1/2, and y-intercept of 1. And then that should tell you enough to graph that. Okay, I'm going to move on. If you need to pause, go ahead. Okay, another example. In this one, it says Ferd charges a flat fee of $50 to walk your dog for a month, plus $2 per walk. Represent this relationship using numbers, which is a table of values, a graph, and an equation. So numbers equals table of values. So you make up a little table, and you say, okay, x. You have to know that we think of dependent and independent. Independent is the x value, dependent is the y value. and obviously the amount of money he makes is dependent on the number of walks. So that's why that's the dependent variable. And by dependent variable, that makes it the y. So for every walk he does, if he has 0 walks, he makes $50. If he walks once, he makes $52 because it's 50 plus $2 per walk. And it kind of goes up by 2 every time. Your first difference is 2. So every time you add 1 more walk, he makes an extra $2. So if I'm going to graph that then, notice I did the squiggly lines just to jump up to 50. And then I could do nice spaced out 2, 4, 6, 8 to 60 here. So at 50, at 0 walks, he makes $50. At 1 walk, he makes 52. At 2 walks, he makes 54, etc., etc. Again, I only need 2 points to graph it. And I did a whole bunch, though. And this time, by the way, notice I have the arrow, because I guess he could walk, and there's no limit to the number of walks he could do, besides maybe by time, but really he'd go on forever. So I drew the points, drew the straight line, and he can't do less than 1 walk. So I'm actually not going to put an arrow on this end. It doesn't make sense to have a negative number, and it could go on forever. Okay, so we've done it with numbers. We've done it with the graph. That's done. That's done. Now let's make an equation. For the equation, we need the slope and we need the y-intercept. Because this is going up by 1s, the slope is equal to the first differences, so m equals 2. You could also get that off the graph here, by the way. It goes when it goes over here by 1. Notice it's 2 boxes. I know that, but because on the scale it's only going over by 1, it's very important not to necessarily count boxes, because by counting boxes it looks like the scale is 1, and that's not true. The run is 1. From here to here it goes over by 1 and up by 2. You have to use the scale when doing rise and run. So if you're using rise and run, you have to be careful there. But anyways, his slope is his first differences, and his y-intercept is right here, which is 50. So the equation y equals 2x plus 50. Y equals mx plus b. Okay, moving on. I think I have 2 more examples. All right, y varies directly with x when x is 3, y is 9. What that tells me is varies directly, you might remember, means it goes through 0, 0. So that tells me a point on the line. And it tells me the y-intercept, right? Because it's starting right here. Varies directly means it starts right there, which means that the y-intercept is 0, b is 0. And then it says find the slope. Now, different ways you could find the slope. I'm going to use every grid to be 1. And notice I put in my second point. So 1, 2, 3, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's the second point. I can now graph it. Like I have plotted the points. Now I can add my line. This one, by the way, could go on forever. So I'm going to add the arrows on either end. Oopsie, that was a mistake. But anyways, you add the arrows on either end, and then you have to find the slope. Well, pretty easy. The slope is rise over run. So you'll say, if you use this point here, which I can't see very well anymore. Okay, so in that time, you've got a rise of 9. So I'm looking at the 2 points starting here, just starting at the beginning. Oopsie. And to here is my run, and my rise is here. And so in that time, the rise is 9 from here to here, and the run is 3. So that means my slope is rise over run. So it equals 9 by 3, or 3. Okay? So I know my slope. I know my y-intercept. I can now write the equation. the equation is 3x plus 0, plus b, 0. Okay, there's my equation. mx plus 0, because b is 0. Okay, this is a long note, but we only have one more example, so let's get on with it. In this question, it says varies partially. That tells me that it does not go through 0, 0. But it does give me 2 points. When x equals 0, y equals 6, and when x equals 5, y equals negative 8. Find the slope and y-intercept. So in this case, it tells us the y-intercept because it says when y is 0, when x, the y-intercept is y, where x equals 0. So at that point, I've just plotted it here, when x equals 0, y equals 6. So that's my y-intercept. I should make this point right here. On your grid, I think I made a mistake when I made it up for you. This line down here, I wanted to ignore it, and I made a new x-axis over here because I wanted to be able to include negative numbers. So just ignore this line at the bottom here, okay? So there's my first point, and just redraw yourself an x-axis. And then the next one is when x equals 5, y equals negative 8. So just 1, 2, 3, 4, 5. And down by 8, there's my second point. So you could find the slope in a few different ways. I chose to use the equation this time. You could just, by drawing the line and doing rise and run would be totally fine. Finish graphing it. Whichever, I chose to use the equation just to have different ways of doing it for you, but whatever you want to do. There's always lots of ways to solve a question. Okay, so using the equation this time, slope equals y2 minus y1 over x2 minus x1, and then you just substitute in the numbers. So my first point, if I said that this is x1, y1, and this is x2, y2, you just substitute the numbers in, and notice it's negative, which makes sense because you look at that graph, it's definitely got a negative slope, and negative 14 over 5. So that's one way you could do it. Otherwise, you could just say, okay, the run is 5, and the rise is how much it drops, which is negative 14. So whichever. And then this 6 again comes from the fact that it starts up here. All right, so that's it. That's a long note, and but that's it for your homework for today, and we'll see you tomorrow in class.